Okay, this is the Algebra 1 6.5 notes that goes with the Big Ideals textbook. So the main concept here is the property of equality for exponential functions. So what this property says is that if we have two powers that have the same base that's positive, so the base right here, this is a positive 2. It's the same, it's a positive number, and it's not 1. If that is true and they are equal, then we can say that their powers are equal. So then up here, this is 2 to the x and this is 2 to the 5th. So we can state that x equals 5. So let's explore this a little bit. So on number 1, notice that it says that 3 to the 4x equals 3 to the 12. So the base is the same. Both numbers down here are 3. And so I know that their powers are equal. So I can say 4x equals 12. I then divide by 4, and my answer is x equals 3. Go ahead and try number 2 through 4 and see if you can finish them up, and pause the video and then come back in and let's see how to solve them. Okay, on number 2, it is x plus 5 equals 20 because both bases are 8, and so you subtract the 5 and you get x equals 15. On number 3, both bases are 6, and so we have 4x minus 5 equals 2x. Now let's go ahead and solve it. Let's subtract the 4x from both sides. And so I end up with negative 5 equals negative 2x. Now let's divide both sides by negative 2. And so I get x equals 5 halves, or 2.5. Okay, on number 4, same thing. The base is still 5 on both of them, so you can set the exponents equal to each other. And so I get 6x minus 3 equals negative 3 plus 4x. Now, all of these, the solving should not be the hard part because we have solved many equations. At this point, your skills in this should be getting fairly good. So we get 2x minus 3 equals negative 3. If we add 3 to both sides, I end up with 2x equals 0, which when you divide by 2, you will still have x equals 0. Now, it gets a little trickier on number 5 and 6. So what's going on here is this is 4 to the 2x plus 11. And we want to figure out what 1024 is as a power of 4. So just think about this. 4 to the second power, 4 squared, is 16. So let's try 4 cubed. 4 cubed is not quite it, so let's go up another one and try 4 to the 4th. Still not quite there, so let's give 4 to the 5th a shot. And you get 1024. So 4 to the 5th is the same as 1024, so I can rewrite it like this. Now, since the bases are both 4, I can now set my exponents equal to each other and say 2x plus 11 equals 5. Now from there, we're just solving it. So we're going to subtract 11, and I'm going to get 2x equals negative 6. I divide by 2, and I get x equals negative 3. Okay, and one way to check this is I can go in and I can just type in my calculator 4 to the power, and then put it in parentheses, 2 times x, so I'm going to do 2 times negative 3, plus 11. And then I'm going to close parentheses, and my hope is it's going to come out to 1024, which it does, and that's what it was supposed to equal, and that's how I know it's correct. So on number 6, go ahead, pause the video, and see if you can come up with what 8 to the power is to equal 512. Okay, so hopefully you thought through that is not 8 squared, because 8 squared is 64. So let's try 8 to the third power, which happens to be 512. So now I can say that 3 minus 2x equals 3. I can now set the powers equal to each other. So I'm going to subtract 3. I get negative 2x equals 0. And when I divide by negative 2, I still have x equals 0, and that is my answer. Alright, so looking over here, pause the video and try number 7. You should be completely ready for it. It's just like number 5 and 6. Alright, so thinking about what 4 to what power is 256. So I'm just going to go ahead and take a guess here and try 4 to the 4th. And so I'm dead on, so I'm just going to write 4 to the 4th. And I can now set 7 minus x equals 4. From there, I can subtract the 7. And so I get negative x equals negative 3. And I can divide by negative 1 and find out that x equals 3. Now, on numbers 8 through 12, they kind of change a little bit. So notice that the base is not the same here. And I don't have 49 to any power. That equals 343, at least not to any whole number power. So I want to go ahead and change this to 7 squared, because 49 is the same as 7 squared. So I'm going to rewrite that as 7 squared. And I know just from practice that 7 to the third power is 343. So I'm going to go ahead and replace it on that side. Now, if you remember in class, what do you do when you have a power to a power? Hopefully you said you multiply them. So think of this as 7, but then you have 2 to the x minus 2. And so you take 2 times x minus 2 equals 7 to the third. So go ahead and you have 2 times x minus 2 equals 3 because you're setting the powers equal to each other. Distribute the 2 and solve. So we're going to end up with 7 halves. So we get x equals 7 halves, which is 3.5. Alright, on number 9, think of this as 6 squared to the power of 6x minus 1, and we have 6 to the 5x. Now remember, a power to a power, you're going to multiply them. So we're multiplying 2 times 6x minus 1, and then we're setting it equal to 5x. So go ahead and distribute here. We get 12x minus 2, because I've distributed the 2, equals 5x. So now from there, I'm going to subtract the 12x, and so I'm going to get negative 2 equals negative 7x. I divide by negative 7, and I get x equals 2/7. I want to leave it as a fraction because as a decimal, it's going to be repeating, and that is not an exact answer once I round it, and so I'm just going to leave it that way. So now, pause the video and see if you can figure out any of the next 3. Okay, so 81 I'm going to rewrite as 9 squared to the 3x. So now set the powers equal to each other. So you have x minus 4 equals, remember a power to a power, we're going to multiply. So we have x minus 4 equals 6x. Now I'm going to go ahead and subtract the x. I get negative 4 equals 5x. I divide by 5. I'm going to get x equals negative 4/5. Okay, so on 11, both need to be changed. So first of all, this is the same as 8 squared is 64. So I want to find out 8 to what power is 512. So I know it's not 8 squared, so let's try 8 to the third power, which it is 512, so I'm going to write that as 8 to the third. So over here I have 2 times x plus 1, and over here I have 3 times x. So go ahead and simplify by distributing 2x plus 2 equals 3x. I'm going to subtract the 2x from both sides, and so I get x equals 2, and that is my answer. Now, let me just show you real quick how you check this. Do 64 to the power of, and in the parentheses, put it's x plus 1, so do 2 plus 1, close parentheses. So you have that number. Now try 512 to the x, which remember x was 2, so 512 to the second power. Notice that both numbers are exactly the same, and that's how you know you did it correctly. So you could check every single one of these and find out if you did it right or not. So on this, 36 is the same as 6 squared, still to the 2x plus 1. So we have 2x equals 2 times 2x plus 1, and we want to go ahead and distribute, which we get 4x plus 2. Now I'm going to go ahead and solve this one. So I subtract the 4x from both sides. I get negative 2x equals 2. Now I'm going to divide by negative 2, and I find out that x equals negative 1, and you could check the same way. Okay, so on these next problems, it's a little bit different because when we think of this, 2,401 is the same as 7 to the 4th. But if we have 1/7 to the x and 7 to the 4th, our bases aren't the same. So another way that we can think of this is we can think of this as 1/7 to the x, and then instead of 7 to the 4th, we can think of it as 1/7 to the negative 4th. Now go ahead and just type in your calculator and try it. We do 1/7 to the negative 4, and because of our negative exponent rules, it's going to flip it around, become the reciprocal, and make a positive power, and that's how it becomes 2,401. So we then know that x equals negative 4. So let's try this one. We have 1 over 512, so we want it of a power of 2. So first of all, let's just figure out what the power is. So let's try 2 to the 6th. I'm just taking a guess here. So that's way too small. So let's jump up a little bit and try 2 to the 8th. Alright, not quite there, so let's jump up one more and try 2 to the 9th. And we get 512. So we know that this at some point relates to 2 to the 9th. So I can go ahead and think of this as 2 to the negative 9th. And if you were to type that in, we could do 2 to the negative 9th, see what it is, and I could go ahead and hit math fraction. And I find out that it's the same as 1 over 512, which is why it's okay to go ahead and substitute it in. So now my bases are the same, so I can set my powers equal to each other. I can add this one over here. And so I'm going to end up with negative 8 equals 3x. I divide by 3 and I get x equals negative 8/3. And I'm just going to leave my answer like that. Okay, so once again, I want to push these into being the same thing. This is a little harder because we're going to change both sides here. So if you think of 25, 25 is the same as 5 squared, where if you think of 625, and we'll deal with the fractions in a moment, 625 is going to be the same as 5 to the 4th. Now, these take a little bit of guess and check, but you will get significantly better at them. So we want to go ahead and we want to have one of these end up as either like 5 to a power and 5 to power, or as, we can have it end up as 1/5 to a power. I'm just going to go ahead and leave this as 5 squared, and then I still have 2 minus 2x. Now I want to figure out what exactly I need to do here to make 5 to the 4th power of some kind be 625. So now, because I know it's 1 over 625, I'm going to try it to negative power and just see what happens. So when I try that and math fraction it, I find out, and it's not going to push it in there, oops, I'm sorry, I should have tried 5 to the negative 4th. So when I do this and I hit math fraction, I find out that it's 1 over 625. So I'm just going to make this be 5 to the negative 4th, because that forces this number in here to be 1 over 625. So remember, a power to a power multiply, so we have 2 times the quantity, 2 minus 2x, and we have negative 4 times the quantity, x plus 1. Now go ahead and distribute, so we have 4 minus 4x, then over here we have negative 4x, and we have minus 4. So now I'm going to move this 4x over here. And so what happens when I do that is I end up with 4 equals negative 4. And so I know that those aren't actually equal, so I'm fairly confident in saying that this has no solution. Alright, so going on in your student journal, we're getting close to being done here, but we want to use a graphing calculator to solve the equation. Alright, so when I want to do this, what I can do is I can just go into the y equals, and I'm going to clear out whatever I have there. The first thing I'm going to do is I'm just going to type negative 9, and then on another one I'm going to type 3 to the, and I'm going to make sure to put it in parentheses, x plus 3. Alright, so when I do this and I graph it, what I end up with is I have the line at negative 9, and then I have my curve. Now I want to see, is there any point in time where these overlap? And so if you look at these, we can pretty confidently tell by looking that these don't overlap, and so I can say, since there's no intersection, that there is no solution. So look at number 17 and see what happens. Let's go ahead and type in the 18, and then down here, I'm going to be real careful about my parentheses. So I'm first going to type 1/4 in parentheses, and close parentheses, and then to the power of, in the parentheses, I'm going to put negative x minus 1. Now when you graph this, your graphs are probably set where they go up 10, down 10, left 10, right 10, so it may not show that line x equals 18. I can go to the window and I can change it, and I can say I want my y to go up to 20 so that I can see that graph. So I'm going to change that. So now my graph shows up, and then my second curve is going to show up. I want to find out where those intersect, because wherever those intersect, that's my answer. So how I do that is I am going to go second and hit the trace button. It says calc. And I'm going to go down to intersect because I want to find where it intersects, and hit enter. So I hit enter saying yes, I want that line and that curve. And it says, do you want me to guess? I hit enter saying yes, I do. And it says that where they intersect is when x equals 1.084. And I should change that to approximate because I did round that. Okay, so once again, on 18, same thing. Let's go ahead and let's type in 3 to the x. So we're just going to do 3 to the x. Now, you cannot do all of your homework like this. The reason is that when you get to a test and we have no calculator sections, you're not going to be a very happy camper. So make sure you don't just start solving all your problems like this, but it is a great way to check them. But all the problems we've done previously like this, you would definitely not want to just solve because we did all of those algebraically, and that's how I would expect them done on the test. So if you look at this, the curves do not intersect, and so this is no solution. Alright, so go ahead and type in the other three of these. Figure out if you think that they're going to intersect and solve for them. Remember how you do it is you do second calculate, you go down to intersect, and you select the two curves or lines that you want, and when it says guess with the question mark, you tell it to guess. And we will check these later on in class. Okay, the last question I have in the notes. This one says you deposit $1,000 in a savings account and it earns 5% annual interest and it's compounded yearly. It wants you to write an exponential equation to determine when the balance of the account will be $1,500. So I want you to think back to that. We had our formula where we had our principal times 1 plus, now remember there's a fraction there, and so here's kind of a hint to you. Up here, this was the number of times it compounded times the amount of time in year. You multiplied that. So if you remember what this was the rate divided by the number of times it's compounded. So compounded yearly is once a year. Here's your rate as a decimal, it's 0.05. Here is your principal. So my exponential equation is going to be $1,000 times 1 plus 0.05 divided by 1 to the 1t. Now if I want to simplify this a little bit, I can have this be 1.05, just type it in a calculator, and 1t we can just write as t. We want to find when that equals $1,500. So what I can do there is I can go ahead and just start from where I'm at and type this into my calculator and find out what the answer is. So this is where it says write an exponential equation to determine when the account balance is $1,500, but the last part is solve the equation. So you could type it in your calculator. One thing I like to do to make the numbers more manageable is I like to go ahead and before I do anything, divide both sides by that 1,000, just because it makes it way easier to deal with. So I have 1.05 to the t, and then I canceled out the two zeros, so I have 15 divided by 10 is 1.5. And what that does, it doesn't change anything if you didn't do that, but it just makes your numbers show up in a much more manageable place. Instead of t, I'm going to put to the x. And it just makes your numbers show up in a regular calculator screen and not making you have to zoom out too far. Okay, it's also just less to type in. So let this graph it. You're going to have the first curve, and you're going to have the straight line going across. Now, I'm fairly confident they intersect. I can just go second calc, and I go down to intersect, and I say that's my first curve, that's my second curve, enter, yes, I want you to guess. And it says that x equals 8.31. So what that means is that after approximately 8.31 years, the amount in the account will have grown from $1,000 to $1,500. And so that doesn't seem like a lot, but when you think about if you invested amounts of money every time you got paid, it would continue to grow, and you're earning money in a bank account without doing anything except leaving it there. You're not doing any work for that. So that's actually pretty cool. So please go back, rewatch the video, pause it where you need to, take control of your learning, really work hard at it, and bring questions in me for class. Thanks for watching the video.